Good morning, afternoon, or evening, and welcome to our webinar. The webinar is called The Drivers Determining the Future of Carbon, and that's a really important topic right now because, as you probably noticed, we're trying to change our source of carbon. We're not trying to get rid of carbon, just stop adding carbon to the atmosphere. But that raises the question, what source of carbon is actually our future source of carbon? My name is Arie van Berkel. I'm Senior Vice President and Group Director here at Lux Research, and I'll be moderating today's session. I'm very excited to announce that presenting today is my colleague Cecilia G, who is an analyst here at Lux Research. So we're going to talk about drivers because the future of carbon is still somewhat in the mist. And our purpose today will be to show you what you can watch, what kind of indicators, what kind of pointers should you be watching to make sense of the future of carbon. Now, throughout the webinar, you can type any questions you have in the questions box on your screen. And as long as we have time, we will answer all of the questions as much as we can. If your question doesn't get answered, then please don't hesitate and email it to questions@luxresearchinc.com. So that's questions@luxresearchinc.com, and we'll get back to you in the mail. All right, without further ado, let's jump into the presentation.
Fantastic, and thank you so much, Arie. I'm very excited to spend this next time that we have together to talk about, of course, one big problem that comes from one seemingly little word. And if we haven't already said this too much so far, that is, of course, carbon, CO2, the carbon economy. And I think this is on everyone's minds these days. And it's not just for our topic of conversation in this webinar today, but you do see very much quite a lot of change, so many initiatives around reducing carbon footprint and CO2 emissions worldwide. So for example, of course, globally, everyone has plans to reach net zero. This means pressure around reaching climate neutrality, decreasing greenhouse gas emissions overall, and also real consequence to inaction, whether that is in the form of political reprimand or otherwise. And speaking of politics, frankly, also crisis, of course, we've also seen how war and the crisis in Ukraine had constricted supply of fossil resources from Russia to the EU, for example. Yes, the EU was reliant for about 45% of its gas imports from Russia, but the EU also responded with a plan to create more energy independence. And just to illustrate an example, that included doubling down on energy efficiency and electrification so that we have enough renewables to supply existing demand and to, of course, support future demand as new markets and new capacities emerge. In addition, the EU also worked on diversifying gas use. So, for example, this looked like tripling hydrogen and quadrupling biogas capacity. So you can start to sense that there's a focus on having both, of course, reliable and diversified sources of energy and of carbon sources while still working towards net zero. And we've seen the example here in terms of how the EU was responding to crisis, but the broader question is, of course, where do we get our carbon? And this is what Arie has alluded to. What are our main options here? Well, there are three main buckets, which include, first up, recycling. So for folks, for example, in the chemicals industry, this is where you would be taking plastic waste, recycling it through your method of choice, whether that's some sort of solvolysis, pyrolysis, and taking that recyclate to reuse again as your source of carbon feedstock in this circular manner. So with this approach, this value chain includes waste collectors, waste sorters, you have your MRFs, your materials recovery facilities, and then of course feeding it back to the chemical company. Your next option then is biomass. And here you might take sources like dedicated energy crops, agricultural crop residues, forestry residues, algae, wood processing, municipal waste, and wet waste. So collecting that and processing it further for use. So in terms of this value chain, you can involve a number of different players, whether that is folks from the lumber or agricultural industries, municipalities, and of course, plant operators. Then you come to CCUS, carbon capture, utilization, and storage. So here you're using perhaps point source CO2 capture directly from industrial flue gas. You might be using direct air capture or DAC. And then you're either transporting and sequestering your CO2 or converting CO2 into value-added products. So this approach, it usually involves the capture developers, the industrial emitters, whether you are a cement manufacturer, steel manufacturer, chemicals manufacturer, as well as, of course, pipeline operators and CO2 utilization groups as well. So when you look at this whole picture, of course, then your carbon can come from different sources with very different value chains. And it's no mistake that this is left to right. So broadly, this is in order from easiest to hardest to do, right? Recycling to biomass to CCUS. And if you are perhaps a chemical company, you will likely want to do them in this order. You likely want to procure your carbon in this order. However, at the end of the day, recycling and biomass alone likely won't be able to provide all of the carbon you need. So for example, if you zoom out, and bear with me, this next image looks a bit complicated, can look a bit old. Well, zooming out, this is a broad overview of how we're quantifying our global energy resources. That is how and where CO2 emissions are circulating. Now, don't get caught up in these numbers. This is in tons per second, but I will point you now to 3 areas and explain this impact in something a bit more sensible in terms of tons per annum. So first is what our impact is. We are looking at roughly 33 gigatons per annum of CO2 that we release from fossil activity, from coal, oil, and gas. Not good. But you might say, hey, Cecilia, you just said that biomass is indeed a source of carbon. Can't we just use that biomass instead of the fossil resources and replace it completely? Okay, that's an interesting point. But you have then, for example, this fossil energy use is about 2.3 times the plant accumulation. So biomass alone will not be able to replace our fossil needs 1 for 1. And of course, replacing all your fossil carbon with biomass will very quickly deplete the ecosystem, which is also not good. I mean, forests and trees and flowers in your own backyard do a pretty good job of abating CO2 after all. And of course, then this is the reason why, for example, there is this tension point around the CO2 that we're releasing, 33 gigatons per year. Of course, half of that is going up into the atmosphere, increasing atmospheric CO2 concentrations, and then realizing that, hey, maybe the plant accumulation and this biomass isn't enough to replace or to abate our CO2. So if you visualize this differently, you can think of it in this sense. So on the left, you can see this is what we're calling the natural carbon cycle. And then on the right, these are our contributions to man-made CO2 emissions with the sort of human or industrial carbon cycle. So imagine again, 33 gigatons of CO2 released per annum. That's our contribution that we have to manage. Now let's assume that a third of that will be electrified. You still have 2/3 left to contend with, and that CO2 has to be abated economically, and that has to be done without relying, of course, on fossil resources. So that means you have around 20 gigatons left to contend with. So let's say you are able to increase at least 6% of the world's biomass to naturally abate some CO2 through afforestation, through other means. Of course, it's difficult, but still, if you were to increase that by 6%, then the rest, let's say at least around 6 to 7 gigatons of CO2 per annum, should be abated through CCU. But it doesn't stop there. The IPCC, so the Intergovernmental Panel on Climate Change, also mandates that we need to store at least 10 gigaton per year of CO2. So altogether, these are the numbers that are necessary if we are to achieve the goals of the Paris Agreement. But 10 gigatons of storage is a lot. And if that number sounds big and scary, that is because it, in fact, is. In fact, you should find it startling because, by the way, there are nowhere near the number of projects announced to make this number a reality. So definitely some shocking news, but don't shoot the messenger. I'm just saying that this is the magnitude of the problem at hand that we do need to act on, unless if you do want some rather hot summers and very cold winters, perhaps, for the next 40 years. So all this to say, CCUS will have a pretty major role to play. And in fact, by our estimates, it could demand around 17 gigatons per year of capture capacity to both abate this amount from atmospheric and industrial CO2 that we've been emitting, and also to align with the 10 gigatons that the IPCC is saying that we need to store. And this amount of capture capacity, that is a lot too. I mean, to visualize it and to imagine with me, that's about half the chimneys of the world outfitted with capture capacity. So that's what's going on. If you recall, of course, there are two things happening at once, though. And I'm alluding this again in terms of, well, this is something that the EU is focused on, but more globally, one. Bringing this back to what I mentioned earlier, capacity is being built up for renewables. That's happening. In Chile and Australia, people are looking at places that have abundant, steady renewable energy, and they're planning on building capacity there and to export globally, even via hydrogen. But the second is, of course, we see through this slide, there is a need to build out CCUS capacity. The approach will first be around, of course, point source capture to help continue the use of fossil resources without sacrificing emissions. So it will bring emissions down quite rapidly. But later down the line, we also need direct air capture, we need DAC, or we need BCCS, bioenergy with carbon capture and storage, to refossilize carbon. And in these two things, there are different drivers, they have different actors. They're happening more or less independently. So the thing is, for you today as a listener, if you're, for example, if you're in the chemical industry, you need to connect those dots in order to thrive, and you need to somehow combine these developments between renewables and CCUS to have the capability to continue to create chemicals. So the rest of the talk is going to focus on that carbon side of things, so that at least from one angle, you can see what options you have. So moving forward with CCUS, of course, I've already mentioned a little bit about this value chain. So what I want to do now is take you through 3 case studies that look at point source capture, direct air capture, and then CO2 utilization. And I'll finish with a little thought experiment and, of course, leave you with 3 final key takeaways at the end. So first up, point source capture. Now, ExxonMobil and Mitsubishi Heavy Industries, MHI, they announced a partnership at the end of last year to provide an integrated carbon capture solution that includes transportation. And they already have a history together. They've partnered in the past to establish petrochemical plants. So what I'm seeing here now is that this decision for ExxonMobil to partner with MHI, which is of course a global leader in post-combustion CO2 capture, instead of a rising startup, suggests and hints at that scale at which ExxonMobil intends to play in the CCS sector. So of course, not just for that history around petchem plant development with MHI, but for MHI's industrial network as well. In fact, if you look at the history in the case studies, MHI already has projects in the works. In fact, they say that their capture technology has already been adopted at 15 commercial plants worldwide and 3 more that are currently under construction. So just for example, this includes MHI's partnership with Drax, a UK utility to use carbon capture with Drax's bioenergy plant. It also includes carbon capture at the Rio Grande LNG project in Texas, and also with hard-to-abate industries such as using their capture systems for cement in Japan, and also for cement in my home province in Alberta, Canada, and also, for example, with aluminum smelting plants in Bahrain. So you can see that this offer from MHI is already being tested in these hard-to-abate sectors. And now what we're seeing is, yes, these 2 corporates provide one of the strongest offerings in the market. So if you are looking for a commercial CCS solutions, engage here. If you don't have a CCS strategy yet overall, you should perhaps think of developing one, as when I look at this partnership, it really signals that, okay, an oil and gas major is solidifying its CCS strategy and approach. But maybe more importantly, this is also an indicator that CCS solutions are going to be available from major corporations, not just startups, and can be used in many different locations with many different industries, even those where maybe you don't necessarily have access to renewables yet. So that was point source. Next, looking at direct air capture. So of course, being able to separate and capture CO2 from the ambient air around us. Now we're going to take a look at Oxy. Oxy has set itself up to make some pretty impressive announcements. It partnered with the Canadian startup Carbon Engineering to accelerate DAC deployment, and that also included commitments to build 70 direct air capture facilities by 2035. And from this, Occidental wants to set up 500 kilotons per annum of capacity. Now, for reference, Climeworks, their Orca plant, which was the first commercial direct air capture plant that was stood up, captured 4 kilotons per annum. Of course, Climeworks is also planning to scale up to a second commercial direct air capture facility. They've called it Mammoth. That's going to be in Iceland with a capture capacity of 36 kilotons per annum. So the ambitions of the, let's say, next leading competitor in direct air capture, of course, Climeworks, their second facility is slated to have a 36 kiloton per annum of capture capacity, whereas we see Occidental being quite even more ambitious and setting up 500 kiloton per annum of capacity. And in addition, if you take a look at Oxy's CCUS strategy, that actually spans the entire value chain. Yes, they have DAC, but they also have point source carbon projects, carbon capture projects, whether that is capture from power, cement, LNG operations. They're also working in transportation, and they've also secured pore space to develop CO2 sequestration sites. They are developing those hubs, in fact, 3 within the US with a capacity of 6 megatons per annum. So when it comes to Occidental specifically, becoming this end-to-end carbon management company and being able to handle, of course, its own emissions and external emissions from surrounding industry in the Texas Gulf Coast is really the approach that they're taking here. And this taps into the capabilities that Oxy already has from upstream and downstream operations. And of course, even though this ambition to set up these 70 facilities in a very quick amount of time, it won't be easy to scale by any means. In fact, I would imagine and think that it's realistic to say, hey, there are probably likely to be delays, but it does signal that direct air capture capacity is going to be built out. So now onto utilization, and that is, of course, taking CO2 and then converting it into a useful product. You can make a lot of things from CO2 already today. We have examples here that you can read when the slides are sent out or through our utilization report that we have accessible. But today I wanted to hone in on chemicals especially. So CO2 to methanol. Here, Carbon Recycling International, CRI, they're an Iceland headquartered company, and they were the first to commercialize its CO2 to methanol technology. And so in 2022, and last year, it began operations of its first commercial facility in China, producing 110 kilotons of methanol from 160 kilotons of captured CO2, and that was captured from coke oven gas and limestone kiln. It's also on track to begin operations of a second plant in China by 2023, so 100 kilotons of methanol being produced. That CO2 is being captured from ethylene oxide production, and its third commercial facility is planned for Norway. That is anticipated to begin operations in 2025, similarly producing 100 kiloton of methanol, but will likely be using renewables, although that doesn't publicly disclose. And I want to delve into that a little deeper because the main reason why CRI has been able to commercialize in China is because its inputs, in fact, are not all green. Actually, CRI itself on its website distinguishes its methanol products. They can call it either renewable methanol or e-methanol, right? Making methanol with CO2 combined with green hydrogen, or what they're calling, in this instance, recycled carbon methanol. So that's combining, of course, your captured CO2, but then hydrogen from other sources, from waste gas, or in their instances here, from the neighboring petchem industry and propane dehydrogenation. So this is a realistic approach to differences in feedstock. And this is an area where they are capitalizing, of course, from being able to abate emissions. At the end of the day, they are capturing quite a lot of CO2 emissions from these plants in China. They're able to valorize what would have been otherwise perhaps a waste byproduct, that is the hydrogen, and they can create a valuable end product. At the end of the day, China needs to use methanol. There's a strong market. So even though the inputs aren't necessarily all green, they've created this sort of interim solution to still validate and produce and convert CO2 to methanol. So of course, CO2 utilization, CCU can provide the chemicals industry, for example, with an alternative source of essential carbon feedstock. And this is an interim solution to accelerate commercialization, which means that as you approach CCU, perhaps with or without renewables, there might be a scarcity in where you are. I mean, depending on where you are and what resources you have, it could be the case where this sort of bridge or interim solution makes sense. But okay, going back to this dichotomy that I posed earlier between CO2 and renewables. Now, the implication from discussions I've heard focuses on only one or the other. Solar in the Sahara Desert, wind scale up in Chile, or CCS in the port of Rotterdam, for example. But can you have both at the same time, and is that cost related? Of course, there is this inevitable need for CO2 removal in addition to direct emissions abatement, and that will result in exponential growth in DAC capacity through the decade. So several large-scale DAC projects in the order of hundreds of kilotons to megatons are currently under development. In fact, projections range anywhere from, for example, 980 megatons according to the IEA, to 1,000 according to Climeworks, to 2,000 to 7,000 megatons based on projections from the Global CCS Institute. On the other hand, the magnitude of that capacity will, of course, be heavily influenced by costs, requiring an understanding of DAC cost drivers and opportunities for cost reduction. Here, we might expect cost to be affected by learning curves, by economies of scale, perhaps by modularity of new systems or technology innovations that can decrease the energy demand of direct air capture, like using electrochemical pathways rather than thermochemical for desorption. So it could be the case then where if you are able to rapidly decrease the cost, increase the scale of direct air capture, then you might be able to flip the script on this either or renewables or direct air capture, and perhaps make direct air capture a lot more accessible. So finally, there are three thoughts I do want to leave you with. First is that emissions abatement is, of course, a balancing act of technologies, both, as I've said, around deployment of renewables and CCUS capacity. So your job here, and it is a very tough job, is to figure out which combination of these developments work best for you. And when you're looking at the factors that play into that, the other side of it is also which source of carbon works best for you. Of course, on this carbon side, all sources will play a role, but again, it depends on your industry and the resources that you have at hand, whether you're looking at getting your carbon atom from recycling, biomass, or CCUS. Speaking of course, then I hope I've convinced you that CCU is somewhat important, especially for industries like chemicals that are inherently reliant on carbon. And lastly, DAC cost reduction could unlock new business models. It could help you connect the dots, and it could mean that expansion becomes much more prolific if cost reduction is reachable. But of course, today, those lower costs, they still remain elusive. It is still very expensive. So there is homework to be done, and there is certainly R&D to be done as well. But overall, I hope that gives you a clear indication in terms of who are these acting players and perhaps what options are available to you when it comes to carbon. Thank you so much for your attention, and I will kick it over to Ari to perhaps take a look at any questions that are coming in. And of course, a reminder, please continue typing in your questions. We will absolutely get back to you after this webinar.
All right, thanks, Cecilia. And indeed, we will now be taking your questions. I've seen some come in already during the presentation, so it certainly is a topic that's alive and kicking, I'd say. So Cecilia, you've shared a couple of really interesting case studies here, and it shows that the space is really evolving quite rapidly. There's a lot still happening. You've discussed direct air capture, and obviously the costs for direct air capture should come down, and they will come down, but we don't know how far they will come down, right? So it seems to me it's a bit early to make a bet in this space if you're a large corporation. At the other hand, you cannot really ignore it either. So how do you propose our clients monitor this space, and what kind of indicators should they be watching to take decisions that are right for them? How do they know what kind of carbon utilization, if any, to embrace?
Yeah, absolutely. And that's a very, very good question. And I know you mentioned this utilization piece. Within the case studies, of course, we talked today about CO2 to methanol, but there are so many other products, whether that is building materials, other chemicals, other fuels, carbon materials even, or even these exotic things like food, proteins, as well as polymers. So, I mean, in terms of what you could do specifically and understand, okay, what are some of the factors that need to be there to pursue some sort of utilization? I'd say it really depends. I mean, if you think of the role anyone can take, you can be the center of a hub, you can be a supplier, you can be a user. So when you figure that out, then I would say, depending on the product of choice, whether you're a supplier, whether you're a user, there's different requirements or there's different incentives for each utilization end product. So for example, you might need, if you are producing a chemical or fuel, in addition to CO2, you would also need hydrogen. You would also need renewable energy. So then does that hydrogen and renewable energy also have to be green? And can you procure it in a cheap and abundant way? Or it could be that you want to sequester CO2, right? Perhaps you're in an area where there isn't a lot of land or there aren't the right geological formations for sequestration. Then it could be the case where, for example, you want to look into being a player in CCU for building materials, because we see that as, let's say, one of the few products that can so-called permanently sequester CO2. On the flip side of that, if you were to look at a fuel product, of course, when you use fuels, you're combusting it still and re-releasing the CO2. So that would be a product that is not up for sequestration. But then building materials with CO2 mineralization does look to be pretty good. Or you could be saying, hey, I really want to make sure I have a good ROI and a good bang for my buck. So in that sense, it would be, well, what about the market size? Building materials is obviously a very, very large market size, and some of these other ones are much smaller. So a few levers and pieces to take a look out in terms of where to play and to consider some of the dependencies or some of the incentives that you want to capitalize on.
Thanks. So that brings me to another question that I can see happening here. People are, of course, quite serious and quite unnerved also about the amount of CO2 that has to be taken out of the atmosphere, right? We're clearly exceeding the carbon budget, at least for the 1.5 degree scenario, probably also for the 2 degree scenario. So the solution to that, of course, is to re-fossilize some of the carbon that's already out there in the atmosphere. It's not ideal, but that's what we have to do. So far, we've seen mostly policies that are promoting no longer emitting CO2, but we haven't seen a lot of policies that promote taking CO2 out, right? So carbon negative is not really a policy thing at the moment. How could policies play into this, and what do our clients have to watch in terms of the policies that could be emerging?
Yeah, no, fantastic question. And I think this also ties into the first question in terms of how do you know when to act, when is a good time and what is a good technology even to bring to the table, policy is such a huge role. And exactly as you've mentioned, Ali, I mean, if you look at these broader emissions restrictions, policies, mechanisms, it's really focused around the restriction, not necessarily taking CO2 out, but again, just restricting it. So of course you have systems in place already, like the EU ETS, emissions trading system. Other areas also have a similar ETS. So China's carbon market, Korea ETS, Tokyo ETS, in the States, you have the California cap and trade. So those are some examples where you have these policies already in terms of limiting emissions. But what we've seen so far is exactly what you've alluded to. Policy so far has been much better at supporting CCS, not so much CCU or carbon negative technologies at all. That is slowly, very, very slowly coming online in terms of conversation, but it's very minimal for now. What we've seen, for example, in the US, in the past, 45Q, the IRA, the Inflation Reduction Act, that's done a very good job at promoting CCS, as I've mentioned, especially the sequester side, including enhanced oil recovery, EOR. But actually, late February of this year, the CCU Parity Act was introduced to US Congress. So that's a bill that was wanting to increase tax credits for utilization to essentially establish parity and bridge and incentivize a wider breadth of utilization in addition to CCS in the States. Unfortunately, we haven't seen so many other announcements worldwide that are really focusing on the utilization piece or the carbon negative piece. But I think that is something to keep an eye out for as organizations and governments are deciding what the best move forward is. And also, because utilization ultimately ends up with these value-added products, where you end up with a chemical, you end up with a fuel, a polymer, a building material. I would also suspect and see, as we have with some of these end products, more nuance and definition around what constitutes a low carbon product. And that will correlate again also to where the CO2 source comes from. So I think quite a, I would say still a misty almost look on the horizon in terms of the utilization piece, carbon negative piece, but something where I would really love to see more activity on. And you see with the CCU Parity Act, the first sort of instance of governments taking a look and bridging that gap.
Yeah, thanks. I'll take one more question. I think we have time for that, and then we need to start closing our session here. But following on that, there's, of course, in Europe, we have the Renewable Energy Directive, RED 2, actually, it's the second one. And it has an interesting way of defining renewable fuels because it just states that you have to have a certain amount of CO2 emission reduction from the fuel. So it doesn't say it needs to be a biofuel per se or anything like that. It needs to be a fuel that reduces CO2 emission with a certain extent. Currently 65%, in the future 70%. 65%, of course, is a clever choice because if you were planning to make fuels out of CO2 captured from a fossil source, you can see it's mathematically impossible to get to 65% because, to your point, you are re-emitting all of that CO2, so you can get to 50% at best. But you could do it with direct air capture, and we're seeing some sustainable aviation fuel initiatives already emerging that are using direct air capture. What's your take on those initiatives?
Yeah, that's really interesting because when you look at e-fuels, synthetic fuels, a majority of those projects, save for a few, are indeed using direct air capture. And so there's been scrutiny in terms of the cost of, okay, converting CO2 to fuels is already a costly process. So your fuel is expensive, and then adding on direct air capture as that upstream capture CO2 source is also just increasingly making this more expensive in such an egregious way. However, I would say that, I mean, you've mentioned RED 2 and what constitutes low fuel or low carbon in a fuel. I would say at the end of the day, I mean, for the aviation industry, for these industries that use fuel, you have in the past already combusted CO2 that has been released into the atmosphere. And so I think the one way to make it, let's say, quote unquote, closing the cycle is it has to be through DAC. And I think that's also where we're seeing a lot of pushes for cost reduction in direct air capture, because that directly relates to your ability to produce a cost-effective fuel. I will say, though, fuel is one area where, coming back to the policy side, there is much more policy that is, you could say, either restricting or promoting certain types of sustainable aviation fuel as well.
Right. Thanks. So we have to leave it at this. I think we could continue to talk for hours about this, and in fact, we do at Lux. But for now, we have to conclude this session. So if your question didn't get asked, remember to send it to questions@luxresearchinc.com, and we'll be sure to get back to you in the email. So after leaving the webinar, you'll be prompted to complete a survey on today's presentation. We would really appreciate any feedback that you may give. It will always help us improve future webinars, and that's our goal. Also, take a moment to check out our upcoming webinars. If all went well, you've been staring at it for a while at our screen right now. Highly recommend looking at our ChatGPT webinar, of course, because everyone's wondering how that will affect the innovation business. And for now, thanks for joining us, and have a great rest of your day.